20-liter container, 400 Kelvin, contain CO2 at a pressure 0.4 atm and an excess strontium oxide, neglect the volume. Volume of container is now decreased by moving the movable piston fitted in the container. Maximum volume of the container when pressure of CO2 attain its maximum value. Pressure of CO2 attain its maximum value. Maximum value attained at equilibrium. Equilibrium pressure is 1.6 because this is a solid. This is a solid. Therefore, Kp is equal to partial pressure of CO2 is equal to 1.6. Now the pressure is 0.4 atm. So 0.4 atm pressure can go up to 1.6 atm. So 0.4 atm pressure can increase up to 1.6 atm. What is question? Maximum volume of the container when pressure of CO2 attain its maximum value. Now the volume of the container here is 20 liter. So pressure increases by 4 times, isn't it? Pressure increases by 4 times. Therefore, volume decreased by 1 by 4. So it is 5 liters. Option 1. So the pressure 0.4 atm. See, the other components are solids. So only CO2 is considered. The pressure is 0.4 atm. And now that can go up to maximum in the equilibrium 1.6 atm. That means pressure can be 4 times. So volume will be 1/4. Volume now it is 20 liter, can be 1/4, 5 liters. Next, 5 liters. Equilibrium constants of the following reactions are given. Equilibrium constant for this is, look at the data to get the answer. You want this equation, 2 ammonia on left hand side. You have 2 ammonia on right hand side. So K1 will be in the denominator. K1 will be in the denominator because ammonia coming to left hand side. So this is out. K1 denominator. So it can be 2, 3, 4. Now, I want 2NO right hand side. 2NO is on right hand side. So I want K2 on top. K2 on top. So this value is out. Here K2 is on top. K2 is on top. Here K2 is there. But taken raised to 3. Not required. 2NO, 2NO. So K2 remain as such. Now left with the 2 and 3. Now I want 3 water molecule on right hand side. Here 1 water molecule and K3. 3 water molecule means K3 raised to 3. K3 raised to 3. So the answer is second choice. So K1 in the denominator, K2 in the numerator, K3 raised to 3 in the numerator. How do we understand? Ammonia left hand side. Here ammonia right hand side coming to left hand side. K1 will become 1 by K. Now 2NO right hand side. 2NO right hand side. K2 as such. 3 water right hand side. 1 water K3. 3 water K3 raised to 3. Hence the answer. Hope you understand. Characteristics of equilibrium. When you reverse the reaction, K becomes 1 by K. When you multiply the reaction with an integer, with a value, K will become K raised to that value. Option 2.